Hello Primary 5 students, how are you? Welcome in your science class with me, Dr. Shaimaa Hamdy Kassem, and your channel, the Big Sister channel. As now, we will study lessons 3, 4, and 5 from Concept 1, Unit 2. So, are you ready? Let's start. Here we have Lesson 3. Activity 5, Particles of Matter. Last time, we said that the matter is made up of particles, very tiny particles that are in continuous motion. You remember that? And we saw the particles of solid, liquid, and gas states. So here we will start by this question. We have two figures, A and B, and the question is, which one of these figures represents the particles of the solid state and why? Yes, figure A represents the particles of the solid state. And why? Because they baked closely together, or they baked tightly together. So well done, grade 5 students. From the information that we learned, that the matter are made by tiny particles, as we said, that we can't be seen by our eyes. We can't see these particles because they are very, very tiny, very, very small particles. So, particles are known as the building units of the matter, as matter is made up of tiny particles. We can see some of these particles by using the normal microscope. So, normal microscope helps us to see some particles of matter, but there are some particles, they are very, very tiny that we can't see by this normal microscope. We need another microscope that we will study after a while, okay, to see these particles. So some of these particles, we can see them by the normal microscope. So if we have a question like correct or wrong, we can see all the particles of matter by using the normal microscope. Is it correct or wrong? So the answer would be wrong, because we can see some of these particles by using normal microscope, okay? And we have here a note that says that the different kinds of matter are made up of different kinds of particles. What the meaning of this sentence? As the particles of gold are different from particles of iron, are different from particles of wood, okay? So each matter or each material has its own particles, okay? Also, those examples for solid matter. If we have particles of liquid matter like milk, so milk is different from the particles of water or oil. Okay, so the different kinds of matter are made up of different kinds of particles. Now we will study different kinds of particles. As here we have solid particles. Solid particles, as you see, the solids keep their shape. They have fixed shape and volume. And this is why, because the particles here in the solid state, they can't slide over each other. With the meaning of slide, yes, to move from one place to another separately or freely, okay? So here, in the solid state, the particles can't slide over each other. The particles in the solid state moves, okay, as all particles in a continuous motion, but they vibrate or move around their places, as you see here. These particles are held together, they packed tightly, and each particle can't move separately from one place to another. the particles can't slide over each other. So we can summarize the particles of solid as particles are closely packed or tightly packed or closely arranged together, and this leads to the result that the solids keep their shapes, as the particles only vibrate or move around their places because these particles are held together very tightly, and each particle cannot move separately. Separately means alone, okay, from one place to another. They can't slide over each other. This is a very important expression here. But if we say the liquid particles, yes, here the particles, they are held together more loosely, okay, not very tight. Loose, the opposite of tight, okay, so they are held together more loosely than the solid particles, so they move faster, as you see here, and they can slide over each other, and this is make the liquid can take the shape of their containers. They don't have fixed shape, and this is why, because the particles can slide over each other. Here we have the gas particles, and as you see, they can spread out to fill up any container they are put in it. So they can spread out to fill up any container that they are in it, and they move very freely, okay? So now we can make model for these particles, as we know how the particles attached in the solid state and in the liquid state and the gas state. So we can make a copy, yes, that we can see it and study it, okay, for the particles by using balls like the ping pong balls, okay. So if we put the ping pong balls packed together, closely attached or closely arranged, so this is will represent the solid state. And if we make or model for the liquid particles, so we will put the ping pong balls loosely attached, okay, or loosely packed. And if we want to make a copy for the gas state, so we will put the ping pong balls are far from each other, yes. Now we saw how the particles in the solid state, liquid state, and gas state, and we made models for these particles by using the ping pong balls. Now let us see this. If we have a cup of ice cubes, okay, and we expose this cup to the sun in a sunny day, in a hot day, what will happen? Yes, the sun will heat up the particles of the ice cubes, and then the particles of the ice will move faster and turn into water. You know why? Because the particles in the solid state, as the ice cube, are packed tightly. They have less energy. They only vibrate or move around their places. When they gain energy from the sun, when they heated up by the sun, what happens? They gain energy. So they will turn to the liquid state, which has more energy and can move faster. So this part is okay. So let us continue. When this bottle of water exposed to the sun, so the sun will heat it up, and the particles of the liquid move faster, and the water evaporates, and we will see that there are like water vapor in the bottle, inside the bottle. And this is why, because the particles of the water gain energy from the sun, okay, and the particles move faster and change into gas state. So again, as you see here, when we have a solid state like the ice cube, okay, exposed to the sun, so the sun will heat it up and the particles will gain energy and move faster and form the liquid, change into the liquid state, which is the water. And when the water exposed to the sun, it will be heated up and the particles move faster and faster, okay, and as they gain more energy and change into the gas state, which is water vapor. Okay, here we will talk about the tiny particles in this activity. The size of particles depend on the type of particles. As we said, that the particles of each matter is different from the other. The particles of iron different from the gold and so on. So the size of particle depend on the type of particles, as each type of particles has different size from the other particles. And we have example here like the red blood cells that found in our blood, okay? Also, the size of particles depends on the connection between the particles, okay? So we have two factors here that affects the size of particles: the type of particles and the connection between these particles, how they are held together, the connection between the particles. We have examples, as we said, like the red blood cells, and we have another example like here. Do you see this? This is one of your hair, and one of your hair has 150,000 to 300,000 particles. You imagine that one hair has a huge number of particles like that. So particles are very, very tiny, okay? So how can we see these tiny particles? Scientists can't use normal microscope to see tiny particles, okay? As for example, we can't see the particles of one hair by using the normal microscope. And this is because the normal microscope isn't powerful enough to see these tiny particles, okay? So the normal microscope isn't powerful enough to see these tiny particles. As by using the normal microscope, we can see the overall of the particles, as we can see a huge number of particles, but we can't see each particle, what inside each particle. So to see the tiny particles, we need to use a special microscope called electron microscope to see one tiny particle, as to see one red blood cell, okay, or the particles of one hair, okay? As we said that one hair consists of huge number of particles. So to see these particles, we need to use the electron microscope. It looks like that, okay? Here, we know that air is made up of particles, but they are invisible. We can't see the particles of the air. So particles of air are invisible, can't be seen, okay? So how to know that the particles exist? So here we will use the air as an example, because air has invisible particles. The thing that shows us that the air is made up of tiny invisible particles: when you blow up a balloon, what happens? Yes, the balloon inflate. What the meaning of inflate? This is a verb that means it goes bigger and bigger. And this is why, because the particles of air inside the balloon move very quickly, because it is in the gas state. Yes, so they move very quickly and they fill all the space inside the balloon. So We can't see the tiny particles of air, but we know that the air is made up of tiny particles that in the gas state and they move very fast. The particles of air inside the balloon move very quickly. They hit and bounce off the balloon from the inside the balloon, so they produce force that inflates the balloon and give it the round shape. As you see here, the particles moving and hitting and bouncing off the balloon from inside like crazy particles. Okay, so they inflate the balloon and give it its shape, the round shape. And what happens when you squeeze the balloon, make it smaller? Okay, so the particles come closer to each other as the balloon becomes smaller. As we know that the particles of gas fill the space. So if the space is big, so they will fill all this space. And if there is smaller space, so they will go closer to each other. Also, they will move very fast, but they will be closer, not very far from each other, to fill this small place. And this is what happens when you squeeze the balloon. The particles come close together as the balloon becomes smaller. But what happens if you squeeze the balloon more and more? Yes, if you squeeze it more and more, it will pop. Why? Because the particles of air inside the balloon will escape out into the air, okay, as the place is very, very tight for them, very, very small to them, so they will pop and they have energy, so they escape to the air and the balloon pops. Okay, here we finished lesson 3 and we will start studying lesson 4. As we have here lesson 4 from concept 1 unit 2, activity 8, models. What is the meaning of model? We have just made a model for the particles of the states of matter by using the ping pong balls. So the model means to make a copy that is similar to the real. To make a copy that is similar to the real. As here we have Earth. Okay, we can't see Earth or study Earth because it's very big. So we make model like the globe. Okay, the globe is a copy of the Earth, have the same things and the same shape of the Earth, and this is to make studying Earth easier. Okay, so models help us to understand things we can't see easily. Okay, because it is very, very big, or because it is too small, like the particles, like the germs. Okay, so here the models may be drawing, to make drawing for these things or objects like the globe, okay, or ideas that represent the real event or object or process if we make a drawing for the photosynthesis process. So this is a model. Okay, so models help us to study or understand things easier, and it may be drawing or objects or ideas for representing objects or process, and the model looks like and move like and work like what they copy. So the model must be copy for the shape and the movement and how the real one works. Okay, we can make models for 3 things, as models for the very, very big objects as the solar system or Earth. Okay, because we need smaller model to study these objects, or models for very, very small, very tiny objects like the germs. Okay, or a model for objects or ideas that we want to understand them, how they work. So now we will start with the models for the two big objects. And why we make models for the very big things in smaller sizes? Because it is hard to see them. So we need models in smaller sizes to study them. We have two examples here, like Earth and solar system. We know that the solar system consists of the sun and the 8 planets, and Earth is one of these planets. You know that. So here, the solar system is a big place that consists of planets and Earth. So we can make a model for the solar system to see the planets at once. All the planets are in front of us, so we can see them at once and compare between them, as Jupiter is bigger than Earth and Mars looks like such planet, okay, and so on. So we can compare between them, we can see them at once, and we can see which one is the biggest and which one is the closest to the sun or the Earth, okay. This is to study the solar system, because it is hard to see it and study it in the real one. Also, we have a model for Earth. We can't see the Earth. So if we want to study it, we need to make a globe, okay, that represents a model of Earth. It has the same shape of Earth, how much are covered by water and land, and the location of countries. So it must be a copy for the real one, the Earth, okay? And as you see here, we see a model as an object like the globe, and a drawing model as the map. As we said, the model may be drawing, maybe object, okay? And we see this project, okay, that represents the solar system. We can see all the planets at once, we can compare between them, okay? Models can be made for the very, very small things, and this is because it is hard to see them, like the germs, okay. So here we have a model for germ. We know some information about germs, like they are spread around us, which make us sick, and we only can see them under the microscope. So we can make a model of germs that can help us to see the shapes of germs without microscopes, okay, as to make a drawing or make object looks like the germs, so we can see and study the germs and see different parts of the germs, and this help us to know how they spread from one person to another, to study the germs and to know how they make us sick, okay. And as you see here in this picture, this is a model of germs like this. Here we have models that help us to understand how things work, and this is the third types of models, as we studied the models of the two big things and the two small things. Now we can make models for things that we want to understand how they work. It is not too big or too small, but we want to know how these things or objects work. Like what? Like a model of volcano, as we can make a model for a volcano to see the shape of volcano, or how the liquids comes out during the eruption, okay, of the volcano, the lava, how the lava comes out from the volcano. This is an example for a model to think that we want to understand. Also can make a model for airplane to see how it flies up in the air. As you see here, this is a model of volcano to understand how the volcano and how the liquids comes out of it. Also here, this is a model of airplane to know how it flies up in the air. So, as a summary for this part, Models teach us about the real things. They are copy of them, and we can see and understand how things work. Know what we can't see because it is very big or because it is very small, and learn about many things at just the right size that we can use, okay? As to make a model smaller, in a smaller size for the too big things, and make a model for bigger size to the tiny particles that we can see them only under the microscope, and so on. So we can make models to learn about many things at just the right size that we can use, that we can see, okay? Now we have activity 9, modeling states of matter. As in this activity, we will make another model by using the beads, okay, and glue and cardboard, and we will stick these beads, okay, to show us the solid particles and the liquid particles and the gas particles, and we will see the arrangement of them, okay? As here we will do like that to show the states of matter and the arrangement of particles in solid. They are well organized, and this is very important expression. The particles in solid are well organized, as we will put the beads arranged closely together in a regular pattern. So they are well organized. And for the arrangement of the particles of liquid, it is not well organized. We will put them organized, but it is not organized like the solid particles. So here we will put the beads are little far from each other and aren't arranged in regular pattern. So here we have the solid particles arranged in regular pattern, well organized. Here in the liquid, they aren't organized, they aren't in regular pattern. And about the arrangement of the particles of gas, so they aren't organized and they aren't in a regular pattern at all, okay? So the difference between the arrangement of particles in solid, they are well organized and in regular pattern, but in liquid they aren't well organized and they aren't in regular pattern. And for the gas particles, they aren't organized, they are not in regular pattern. We have lesson 5 from this concept 1, unit 2, and we have here like a game, as we have many objects like what you see here. We have rice, we have steam or water vapor, we have vinegar, we have oil, water, frozen vegetable, and we have natural gas, and we have pasta, and we want to sort them as which one is solid and which one is liquid and which one is gas, and we will put as S for solid, L for liquid, and G for gas. So you do it. Yes, as you see here, this is the answer. Well done, primary 5 students. Here we have information that you know that chefs use science during preparing dishes. Yes, because they are dealing with these ingredients that you sort them like solid, liquid, and gas. So they use science during preparing dishes. As boiling water for cooking rice or pasta, water changes from the liquid state to the steam, which is the gas state. And freezing vegetables keep them fresh for a long time, okay? And this is the solid state. And keep juices in the freezer changes them from liquid state to solid state. With this information, we finished our lesson, so don't forget to like, share, and subscribe my channel. Thank you for watching. See you next video, inshallah, and goodbye.